So for this question, it said a conical tank of the height 8 meter and the surface radius 30 meter shown in the diagram below. The oil is pumped into the tank at a constant rate. So when you see this constant rate, meter cube, it represents the volume. So dV dt equals to 45 positively because your oil here is pumped into the conical tank here, which means that your volume of your oil here, they are increasing. So therefore the rate of change will be positive value. If the depth of the oil, so the depth of the oil we indicate it as H. So H is 3 meter. Find the rate of change of the oil depth. So the oil depth will be dH dt. This is going to find and give the answer in 3 decimal place. When we getting this optimization problem, the first step is we identify the information and the shape given. So from here we can know that our variable here involving when your oil is pumped into this conical tank, variable will be its height and its radius. So as your oil is keep on increasing, your H will be varies and your R will be varies. So H and R of the oil will be your variable. So second step, if is we are going to find dH dt. We form out the chain rule to find this dH dt. We need start from dH, ending with dt, and the quantity we can link here is, you can see we are given dV, so most probably we can link here with volume. Then continue. For the third step, means we need to find out our volume in terms of H so that we can differentiate V with respect to H to substitute this information into our chain rule. So volume. Volume of the oil is follow the container shape. Since this container shape is a conical tank, so this volume of the oil also in the shape of conical. So conical volume, it will be 1 over 3 pi r square h. So this is the r radius and this is the h. And we can see we want v in terms of h, means that our r here we need to substitute in terms of h. So from the container here we can identify another information where this radius is 30. We can use similar triangle. From the conical tank, it is fixed 30 and the height is 8. From the oil, we have a variable r and variable h of the depth of the oil. So actually you can see these two triangles, they are similar because they are having the same angle. As this angle is similar to this angle they are holding the same. So therefore here we can come up the similar triangle and doing the ratio. So we're going to substitute r, therefore r ratio to h, it is equal to 30 ratio to 8. So r will be 30 over 8 h. So simplify this, we get 15 over h. So we can substitute here 15 over 4 h squared to represent the r. So next we're going to expand this. Where 15 over 4 square and 15 over 4 square times with 1 over 3. We take out the coefficient first. we get this one 75 over 16 pi. Then h squared times h, we get h cubed. So now we can differentiate v with respect to h. Differentiate here, it will be power move to the front and power minus 1. And what we want here is dh dv is not dv dh. So we will inverse, we write it properly, where numerator is this, denominator is 16. So when we inverse it, it becomes 16 over 225 pi h squared. So step number 4, where we're going to substitute all the information into our chain rule in order to get the dh dt. So start with dh dv that we found just now, and time with dv dt information in the beginning of the question 45. And we look on this rate of change we want to find here, we still need the value of h. And the value of h also given from the questions, which is the value of the h is equal to 3. Then our answer here has to be let it to 3 decimal place. So 113. So height, we see the unit. The unit here used most of the time is meter. So meter per the time. The times used is minute. So 113 minute, meter per minute.